ahead and pull out some highlighters because there's some cool stuff in here. All right, so this page is the factoring of polynomials, and hopefully you've seen this all before. This is just review for you. So the first thing I want you to highlight is GCF. Whenever you're factoring polynomials, the first thing you should always look for is GCF, which stands for?
Greatest common factor.
Yes, greatest common factor. Greatest common factor can be numeric and can be a variable, right? You can have variable parts that is a greatest common factor and numeric, obviously. All right, so the first factoring pattern that we're going to talk about is one called a difference of squares. The difference of squares only works if it's a difference, hence the word difference, and both of your terms are perfect squares. Okay, so for the first example, we have x squared and we have 64, and it's a difference. So does it follow the pattern? Yes, it does. X squared is a perfect square, and 64 is a perfect square, and we're finding their difference. Okay, so the pattern is going to be to take the square root of the x squared, which is x and x times x, the square root of 64, which is 8 times 8. One of them is plus, one of them is minus. Doesn't matter what order.
No, because they're multiplying.
No. Any questions on that example? All right, the second example down here definitely has a GCF. So when you look at the first term and the second term, what is the GCF of 18m squared n minus 2n cubed?
18.
Well, 18 goes into 18, but 18 does not go evenly into 2. So 18 is too big.
So 2.
2, okay? Everybody agree on the 2? 2 goes into 18 and 2 goes into 2. What else?
9.
Well, 9's going to be left. But remember, I said there's a numeric part, and sometimes there's variable parts.
So n.
Yep, there's an n there, and there's at least one n there, right? Okay, so the GCF, greatest common factor, is your 2n. Somebody already said the 9, which is what's left inside.
What's left of 1?
9m squared, that's what's left of the 18m squared n. And minus n squared is what's left of the negative 2n cubed. Okay? Now that you have the GCF'd out, see if it follows the pattern of your difference of squares. And it does, because this term is a perfect square. This term is a perfect square, and we're finding the difference. So we're going to take the square root of this, and we're going to take the square root of this. What's the square root of 9m squared? 3m, and then obviously the square root of n squared is just n. When you write it as the final factors, make sure you write that GCF, okay? So it's 3m plus n and 3m minus n. Now, I know I said it doesn't matter the order, but generally you write the GCF first. I mean, technically you could write it in the middle or you could write it at the end, but it's just kind of not standard too. Okay? Any questions on either of those two? All right. The second pattern is your trinomial. Notice this one's also trinomial, but this one is going to have a coefficient other than 1. So this one is just your easily factorable trinomial. Generally has a leading coefficient of 1, where you're going to find the two factors or the two numbers that multiply to get your C, but add or subtract to get your B. So for the first example, excuse me, we have x squared minus x minus 42. This one I would consider easily factorable. There are two numbers that multiply to get negative 42 and add or combine to get negative 1. Anybody think they know those two numbers? Leah? What did you say before 7? Negative 7 and positive 6. So when you factor it, it looks like this. X minus 7 and x plus 6. Good job. Okay? All right. The second example has a GCF. 2w squared plus 20w plus 50. What is the GCF here? Just 2. No variable part of it. So if you factor out a 2, you're left with w squared plus 10w plus 25, and then it's easily factorable. What multiplies to get 25 and adds to get 10?
2.
What?
Oh, 5.
5 and 5, right? They're both positive because both of them are positive.
I always said 2 because of John. He threw me off.
John threw you off.
Yeah.
It's all John's fault.
Come on, John.
This one has 2 different ways you can write it because the w plus 5 and the w plus 5 are the same. You can write it as squared or you can write it as separate. Any questions on the easily factorable trinomial? Okay. The other trinomial is where you're going to have a leading coefficient other than 1. So this a right here is sometimes a 3 or a 5 or a 7, sometimes a 2. And there's this method called the slip and slide. But most of you I've seen use the little box thing, right? Yeah? Yes, okay. So I'm going to show you with the box, and then I'll show you this little slip and slide trick. The box and the slip and slide are both just like tricks that you use to solve these easier. Easier? Is that the proper English? But first we want to see if there's a GCF. Is there a GCF of 30x squared minus 27x plus 6? Yes?
6.
3. Well, 6 goes into 30 and into 6, but 6 does not go evenly into 27. You could. But we're just going to factor out a 3 for,
Well,
3 for now.
Oh, it doesn't have to be in the equation?
It has to be a factor. Your GCF has to be a factor of all of your whole polynomial. How many ever terms? In this case, there's 3 terms, right?
But it doesn't have to be.
Has to be a factor of all 3 terms. Okay? That leaves us with 10x squared minus 9x plus 2. That's the part of the slip and slide trick, which I'm going to show you second. First, I'm going to show you the box.
I was just going to ask that.
Okay. So right here is your box, right? You've got your 10x squared, your plus 2. You have to see what is going to multiply to get 2, which would be a negative 2 and a negative 1, and add and subtract to get negative 9x. So it ends up being 5x times 2x to get your 10x squared, 2x times negative 2 to get your negative 4x, and 5x times negative 1 to get your negative 5x. You guys all know how the box works?
Yeah.
Yeah? Any questions on the box? Because I'm about to show it a slightly different way. It's called the slip and slide trick. Okay? So you're going to take the coefficient, not the GCF, but just the coefficient of your x squared, and you're going to multiply by the 2. And that's the slip part. You're going to slip it down and make it to 20, right? So now you've got x squared minus 9x plus 20, which is easily factorable. The 2 numbers that multiply to get positive 20, but add and subtract to get negative 9 are your negative 5 and your negative 4, right? Same thing as what you would do in the box trick. So we're going to rewrite it as x minus 4 times x minus 5, but then you need to divide each of them by the 10 that you just multiplied by. Then once you reduce it, reduce that 4/10 all the way down to 2/5, and that becomes your 5x minus 2. Then you're going to reduce your 5/10 down to 1/2, and that becomes your 2x minus 1. You're essentially doing the same thing. It's the same, it's just different. It's the same, it's just different. It's just two tricks
Yeah.
doing the same thing. Okay?
You should play a song called The Box by Roddy Ricch.
Oh, yeah?
It teaches you about the box.
Oh.
It's how it is.
So you can use either method. If you prefer the box, stick with the box. Like, if you're good with that, use it. Okay? It works perfectly great. Okay? The last factoring method you rarely see, but it's called factoring by grouping. And it works when you have 1, 2, 3, 4 terms, which you won't see very often. Okay? So you're going to take the first 2 terms and group them together. And then you're going to take the second 2 terms and group them together. Please note that the second 2 terms need to include whatever sign you have here. This one's easier because it has a plus. But when you have a minus or subtraction, you're going to want to pull that out. So when it has a subtraction right here, it makes this just slightly harder. Not a lot, but you guys. Just make sure you include that sign in that grouping, okay? With the first grouping, you're going to look for the GCF. So the greatest common factor of 2a cubed minus a squared plus b is a squared. So you factor out the a squared, and that leaves us with 2a minus b. For the second grouping, you look for the GCF of 10a and negative 5b. And that GCF is 5, which leaves you with 2a minus b. Notice that this 2a minus b and this 2a minus b are the same, okay? If they're the same, which they designed these problems to be the same, that becomes one of your binomials. And what's left over becomes the other binomial, the a squared plus 5. Okay? Any questions on that?